when I'm asked to write the equation of a quadratic equation, I can use one of three different forms. I can use vertex form, intercept form, or standard form. We graphed with those three forms previously, but let's go ahead and write equations with those. So for our first example, I'm given 2 points. I've given the vertex and I've given a point somewhere on the parabola. Because they've given me the vertex, no surprise, we're going to use vertex form. If you recall, vertex form was this: y equals a times x minus h squared, and then plus k. So as we've done in the past with writing equations, let's go ahead and try to replace some of these values with numbers and solve for whatever's missing. So recall that the h and k represent the vertex of your parabola. So I'm going to go ahead and replace h and k with those values as well. So my first step is going to say y equals a times x. Now I want to have positive 1 for my vertex, so in parentheses, remember I've got a negative 1. That horizontal shift always does the opposite of what we think, so a negative 1 will actually move my vertex one space to the right, and then my k value is going to be a minus 2. That vertical shift does move the graph the way it says. So h and k have been replaced, but I still have too many variables. I've got y and a and x. So I have one more thing that I can do. That's why they've given me the point. The point of the point is that we have more values to plug in. That's my x and that's my y value. So for my next line in my work, I'm going to have y replaced with 2. A is still unknown. A is always going to be the thing that we're trying to find. X is 3, and then go ahead and rewrite what we've already plugged in. So if I take a look at what I have now, I've got an equation that only has one variable in it, which means I should be able to solve for this. Let's go through this and simplify and rearrange a little bit. So I've got a, now in parentheses, let's just do order of operations. 3 minus 1 is 2, and 2 squared gets me 4. So this is a times 4, and then minus 2. Be really careful at this step because people want to do 4 minus 2, and that's not order of operations. A is being multiplied by 4. So let me rewrite this in a more convenient way. Make sure I say 4a minus 2, so I am following order of operations and not subtracting things that are not like terms. So add 2 to both sides, and then divide by 4. So it turns out that a is equal to 1, which tells me a little bit about the parabola. It tells me that it's going to be opening upwards. It's telling me it's not been stretched or compressed. It's going to be the same width as the parent function. Don't forget what we're trying to do, though. We were trying to write the equation of this parabola. So now that I know what a is, I can go back to this point right here in my work, and let's replace the a with the 1 that we just found. In your final answer, x and y will still be variables, so I'm going to say y equals a we just found out to be 1. And then I'll get my h and k values plugged in because I want the vertex to be at that location. So here's the equation of the parabola that would fit that data. If I wanted to check this, it's easy enough to do. We could graph that parabola by hand or on a calculator, look at your table, and just make sure that those two values show up in your table.